Could you create a programming language for AI pair programmers, or maybe as an agents as code sort of system using the new OpenAI Strawberry? In this quick video, I'm exploring flexible-based programming languages, specifically document-style programming languages. We're looking at grammars and parsers. Let's get into it. For context, I'm building an AI workflow designer, and we can see one of the designs here for my YouTube launch, which is when I'm publishing a video. For instance, I might want to find the chapters in a transcript and then turn them into clickable links in the YouTube description. As an example, I've got this video from last week where I have a YouTube description with chapters and related videos, and all of this was done through the workflow. Now, the workflow was created using this little document that I created called YouTube Launch Optimizer, and I'm just showing the old version. It's basically a coding language. It's an internal DSL, and as I would change values within this language and press save, it would generate the screen that you're seeing down below. I want to build dozens of coding languages or domain-specific languages designed for working with large language models. So what I did was I started writing a new version of it, and I used my GPT workflow engine to write a lot of this code based off this one as an example. The key differences is that the one on the right is an internal DSL, so it has access to variables, it has access to methods. The one on the left doesn't. It's an external DSL, so that sort of stuff wouldn't work. But there's benefits in that I now have control over how the language looks. If I want to add new concepts to the language, it's a lot easier with the version on the left. When I'm working with the older technique, these methods actually get called. This would save the document to a database and to a JSON file in an Astro website and just re-render the screens. Whereas the one on the left is going to use more of an actions-based approach, which will still have the save and the saved, and we can add in other concepts like save to crew AI if I want to automate a workflow. Now, after building this DSL using a workflow that I developed specifically for creating DSLs, I thought it'd be time to start looking at the documentation. I created both an examples of how different things are meant to work and a rules document, and we can see a visualization of the rules document right here where I'm talking about different data types, how parameters are meant to be dealt with in different elements, how containers work. I've developed all this information and we're going to use it as seed for OpenAI's Strawberry model. Now we come over to ChatGPT and I've got this O1 preview set up, and I've put in the word read, and then I've taken the documentation that we've got. Here's all the DSL rules and here's all the DSL examples. Now I haven't written anything else, but we can see here we got a chain of thought for 18 seconds. In my last video that I did 6 use cases on Strawberry, one of the things I noticed was that not always did it do much better. It'd do a little bit better, it'd go a bit more detailed, but the one thing it does so well is this area, the reasoning, because this allows you to check how it's thinking, and at any point in this you could also make the decision they made a mistake here, and that's what we'll ask them to rectify on. As we look through this, we got analyzing the DSL details. So it's examining the content to understand my intent. Then it's reflecting on what's probably the hardest area of this DSL. It's the parameters, because they support positional, named, splats, double splats, all sorts of structures that have to be dealt with being looked at the moment. So it's crafting the code, crafting the workflow, looking at the YouTube strategies. I've only given it rules in this area around parameters and data types. Then I gave it the argument rules, which is the positional, the optional, the splat, the keywords, and the double splat. This is where it started to diverge from Ruby, which has concepts of blocks, but I'm seeing that structure as just being a nested hierarchy or a container. And I've told it about the order and the constraints. So how can parameters on a method definition be set up? Really simple snippets that associate a rule to an example. For instance, a single node that might have a list under it is being shown here. So we've got a workflow, there's a single node called settings, and then there's a list of setting underneath it, and this is how the definition would look. I added one other thing into this prompt, and you can see here the definition workflow. Where that first came from was AGP 4.0 definition, which was designing a definition. So this is kind of like a grammar for the DSL, was firstly designed in ChatGPT 4.0. Got a few mistakes there, so I took that over and manually altered it over here. So for instance, the workflow should be able to take a name, a parameter called name, and it should just take up the first position. After that, there can be a node called description, which will take a parameter called description as well in the first position. We've got the settings, and after that, a node called settings should repeat, and it's declarative, meaning whatever the key is will be derived directly from the method name, and after that, there'll be a value. Now we've got a generated DSL, and it's looking very good. I could almost use this the way it is. I'm going to click copy here, and we'll head over to Visual Studio. I have an example that I hand wrote, and I put in concepts like multiple sections. We can see section 1 and 2, and multiple steps. Let's go and put the new one, the Strawberry one, into the system. And here we have them side by side, the old one on the left, the new one on the right. So it's modified a little bit of text, which is great. It's taken more my placeholder prompt ideas and filled them out with useful names. And it's noticed that I've called it content, which in my older one before I would load that from a file. So I have file concepts here, but it's thought, no, this is content, so it's going to do more of a prompt sort of approach. And then it's still done the sections and the steps. It's got good naming conventions for section, steps, input parameters, what are linked through to the prompt, which would be up above, and the output. And if we go down to the bottom, it's just made it a little bit cleaner in the file name saving. This is looking great. Let's look at the main prompt that I now want to work with, and I typed a lot of this in by talking into the computer, so there's some grammatical issues. I said when I gave you the definition file, which was its own DSL for defining DSLs, a grammar, I said the goal is to build other DSLs, and the DSL you've produced is spot on. So I've told it, or affirmed, that what it did above is actually correct. Next, I wanted to explore parsing libraries written in Ruby, so 30 words per item. I need to know whether any of the repositories are old, because I don't really want to work with old code that might be unmaintained. I've then gone on to tell it that the goal of DSLs is really just to convert it into a data format that can be read by a machine, in this case JSON. Next, I wanted it to think about merging the data from the DSL with whatever the user-generated content is, with the metadata, such as should a value be an integer or a boolean. I've said ultimately it needs to be used by a JavaScript application, because this is going to be embedded into Visual Studio and Monaco, so I can use this technology either in a web application or within the IDE. But what I don't want it to do is start exploring this. I've told it explicitly that to think about it, because it needs to know about these LSPs, code completion, linting, all this sort of stuff, but I don't want it to go deep. I just need it to be informed. I've also told it in the next 2 lines that I'm probably going to build my own engine from scratch, and that means I'll either take inspiration from 3 or 4 different libraries that are already out there. Part of the reason is this is quite a simple parser in some respects. It's not like a programming language where I need to understand variables or method calls, or even the mathematical conventions of 3 + 5 times. This is more like a XML structure or a JSON structure. It's a hierarchical document. The chain of reasoning, it went for 34 seconds. Let's expand that and see what we got. We're examining the definition file. It understands that I liked what it came up with. It's evaluating different libraries and weighing the pros and cons. It's worked out that it's converting a DSL to JSON. It'll craft a parser. It will consider the fact that the schema structure needs to be included. It's made itself aware of the JavaScript wrappers for IDE use, specifically around code completion and syntax highlighting. It's now assessing whether we should reverse engineer an existing tool. I notice in a lot of the chain of thoughts that it's always doing this. The response needs to be compliant with OpenAI policies. It's probably trying to deal with jailbreaking issues here or other sorts of compliance issues. So now it's crafting a plan for 3 libraries. It's evaluating Treetop, Parser, and Ripper. It's looking at the maintenance status. It's basically found this library. We've got a GitHub repo, we've got Rack, when we've got Treetop. What I liked when I saw this was that this is the sort of grammar I really want to work with, something really simple and easy to extend. Now with the evaluation out of the road, it's looking like it's getting into the coding itself, so transforming the JSON, crafting a part. So it's now explored 3 different libraries. We've got Parser, Rack, and Treetop. We've got pros and cons. Most of them are actively maintained. It then did the transforming of the DSL to JSON. I've written a JSON format already called YouTube Launch Optim, and we'll just copy over the Strawberry version. The one on the right is Strawberry. You look at this and it goes, well, it doesn't have a type of root and it doesn't have a type of node, but it doesn't need them because it's implied through the fact that it's got a definition and it's got nodes. So that's kind of implied just through the wrapper. Here's where it gets really powerful. So one of the things it did here of having the type of node and the repeat, this was actually done by GPT-4, and it's way more accurate in the Strawberry. Take for instance the repeat. You can see what this is meant to be. There's settings followed by a bunch of key value pairs. Now the thing that's actually repeating are the key value pairs, not the settings node. And in the GPT-4, it's got repeat as true to the settings, whereas here it's got an array of nodes of which they have type setting. It is repeatable and it has a declarative key. The declarative key means that rather than saying setting plus a key and a value, the actual method name is the key, and then it's followed by a positional value that we can see right here. And then we see a lack of information purely because we're now not including the actual values that were found in the DSL. Let's look at settings versus prompts because there's some subtle differences going on here. The first is that there is a repeating prompt. Here there is a repeating setting, but in this place the method name becomes the key, whereas this doesn't happen in this one. It instead takes a name as a positional parameter followed by a named value called content, which will take a value as well. So if we move down and we look at what it's done, we can see that it's removed node, which is great, and it's moved repeat to the correct location. This time, rather than being declarative, it's positional. Followed by that, it's got a named type with a default value of empty string. One of the simplistic rules that I have in my documentation is that there's no need to state whether something's required or not. If it has a default, it's optional. Closing off this analysis, we've got the sections, we've got the steps, and we can see that being mapped correctly. Simpler because we don't have the extra versions going on. And then if we get down to the bottom, let's see what it's done with actions. And this is great. It's just got an array of nodes. One is called save. It doesn't take any parameters. And one is called save JSON. It does take a positional parameter called path. Let's now move into tokenizing and parsing. Now it's given us some starter code, but there's no logic going on here. This is basically identifying the strings, the tokens, when a block starts, when a block ends, and turning it into a list of tokens that can be used by the parser, which is down below. So it takes as a parameter a list of tokens and then the rules, and the rules are embodied in the schema. So let's have a look at how that fits with the existing code. So with the tokenizer, what we're trying to do is work with the particular DSL that we've got, in this case the workflow one, and we're trying to separate the concepts like the first definition node, which is called workflow. There's a field or a value going in here, there's a start of a block. At the very bottom there should be the end of a block. So these are the different tokens we're trying to get. Do we have a method? Do we have a string? Do we have a symbol? Further on, if there happen to be integer count is 3 and @div is true, we would want to be able to read that out and notice when we've got a Boolean integer sort of value, when we've got a positional parameter. This is what the tokenizer is designed to do. But if you move down a bit further and look at the parser again, it's going to take the stream of tokens that we got from this particular file and work through the schema definition, and the schema definition is going to be read out of this file. So it's going to look for a concept like definition, which has workflow, and try to match it to the DSL, which also has workflow. If we zoom in on this section here, what we can see is that there's a search for a do block, and there's an expectation that there's an end block after it, and there's a recursion going on. The parse node is calling back through to this method. Hopefully it's going to split out each of these do blocks and the end blocks and capture all the information in between. A bit further on in this particular parser is other information like parsing the parameters, and there would need to be a mechanism in here to make sure that the parameters coming through in the DSL match the rules coming through in the DSL definition. As we scroll a bit further down into this code that's been generated, we can see how it would be called. So the DSL code would read through from the DSL that we've written, and from there it would be tokenized. The tokens would come through. They would then be passed in with the scheme, which would parse it, and then we could have a look at the output stream after that. The considerations that we're seeing here, they're going to be really useful in the future of this project. This is going to be written using Cursor, and Cursor will rely on a lot of this documentation and ideas to write the correct code. So I was looking through this. One of the areas that I didn't notice was the ability for it to deal with self-closing nodes. So I have nodes such as the 3 that are listed here, or any of these ones that don't have a do or an end block. They just have a carriage return at the end of that's the end of that node. But what's interesting when you come back to the code that's been generated, they've got a 4th area, writing a parser without external libraries. If we zoom in on that, we can see simple DSL parser, and there's a case statement going on with 3 different areas. It's looking for the do block, it's looking for the end block, and it's looking for the self-closing parameter. I'm not exactly sure how this simple DSL parser that we've got here relates to the tokenizer and the parser above, but at least it's thought about these codes and we can analyze it a bit further. If we move on, it also gives a whole lot of extra information that'll be used by the pair programmer when I'm using Cursor or Claude Dev to generate the code. It's giving further insight, which is represented in the requirements document, but also added to this area around parsing parameters, the positional, the named, and the declarative. It doesn't talk too much about the splats or the double splats, but that's in the requirements document. We've got the repeat flag, which is when a node can be repeated multiple times. And then we've got a pros and cons in using this particular technique. Now, the additional considerations are more useful for the JavaScript wrapper that'll be used by Visual Studio, but it's good that the information is kept here. Finally, we have a conclusion and next steps. So I've grabbed all the information here and we've come over to Visual Studio. I've got a file called brief, and we can see all the information that was in the original ChatGPT window has been made available in a markdown document. This will be good for when I use Cursor to build the application, and I've gone and started the implementation by just copying the code and just wrapping some namespacing around it. So we've got the parser, we've got the tokenizer, and I've just left the sample usage right here. Now, this particular project that we're looking at, I've just gone and uploaded it. So there's a new version. I did it as a feature. So if I just go to my gen, we should be able to see a new version of it. We're at version 1. If we click on it, you should be able to access it yourself going to the GitHub repo. So the feature 6 minutes ago has been added. You can find the documentation here. You can find the code within this section. Other things to notice about this is that I use DSLs all the time for different problem domains. For instance, I story cards, and the project plan is written creating a DSL. It gets visualized using DrawIO, which is a graphing tool. We can see some of the things that we want to work on in this particular project being displayed right here. You can just come and pull it from this Git repo. In the next video, what we're going to do is continue building this sample project. It's part of a bigger project where I've got Visual Studio Code extensions, we've got Monaco extensions, and a programming language that I'm developing called Clueless, where the clue is to do less. I'm Happy Dave. Please like and subscribe, and I look forward to seeing you in the next video.